Okay, problem 5. So let G be a group with the operation star, and let H be a group with the operation hashtag. Define the direct product G cross H. Okay. So this is so the direct product is a new group that you can make from two previous groups. And so here's what it's made of. G cross H is the group with the set. So unfortunately we use the same notation for just the set, which is what's kind of confusing about it. Now the set, of course, is... Oh, that's right, there's no undo button on this, that's a shame. G, H, the set of all ordered pairs, where G is from here and H is in here. Now it's important though, and I gave you points if you didn't, but it's important to also say what the operation is. Where here's the operation. If you got two of these things like G1, H1 times, or you can use whatever symbol you want for the new multiplication, G2, H2. You calculate the new ordered pair in this new group like this. You multiply the G1 and G2 together in the left component with whatever operation they had going on in G, and you do the same thing to the H's with whatever operation they had going on in H, right? Yeah, so star and the hashtag are the operations, the letters are the individual elements of the group, of course. Okay, so there you go. So that is the direct product G cross H, is that group with that operation. Sorry, that set with that operation. Now next, prove that G cross H is isomorphic to H cross G. Yeah, that's true. So if you do if you make the same group but the other way around, where you have the H stuff on the left and you have the G stuff on the right, you get a different group, but it is indeed totally isomorphic to G cross H. Now how do you prove that? Well, you have to come up with an isomorphism, a function that goes between them. And it could go the other way, it doesn't matter. You need it to be homomorphic, or a homomorphism, and you need it to be bijective. Okay. Yeah. So what are things like over here? They look like this, right? They look like individual G's and individual H's put together. So here's a great way you could define phi. What if it just it literally does nothing other than it just does that, right? It just moves them the other way around. Is that a homomorphism? Yeah, probably. Let's see. So first of all, you got to make sure it's a homomorphism. So that means phi of a product of two things. So again, I'll use G1, H1. That's getting kind of ugly. Maybe I should use, I don't know. Let's say A and B are in G, and X and Y are in H, or something like that. Yeah, so what we want, we want to show that this is the case, that it's the same as A X times phi of. So we'll see if that's true or not. So let's work this out. So first of all, let's apply those things inside the function, apply the operation inside the function. So we know that we have A star B, right, because those are in G, and then we have X hashtag Y, because those are in H. Okay, and then phi says just flip them around. Okay, I'll flip them around. So that's going to be X hashtag Y, A star B. Okay. So notice now we are in something which is, right, this is in H, and this is in G, which means this whole thing we are now in H cross, what the heck am I doing? I'm confusing myself. We're in, why isn't that going the way? We are in H cross G, right? And in H cross G, you can write this as X A and Y B. And what's great about that is indeed this is equal to the flipped around version of AX and the flipped around version of BY. And so sure enough, if you take a look at what we got going on here, we said that phi of this times this is equal to phi of this times phi of this. And so that's exactly what it means for phi to be a homomorphism. The important thing being that those things were, could have been any element of the sets in question. Okay, so great. So we know it's a homomorphism. Oh boy, that was the whole page. How do we know it's bijective? Well, bijective is pretty easy, right? I mean, to be onto, of course, there's something that you just, with the flipped around version of yourself is what it takes to get flipped back onto you. So of course that exists for everybody. And then injective, I mean, yeah, you just flip it around. So there's no way two different things that are different pairs are going to get flipped and become the same thing. No way, right? So you just say that in some form or another, and there you go. So it turns out that phi is a bijective homomorphism, which means it's an isomorphism, which means indeed these are isomorphic. So no matter what G and H are, G could have been D5 and H could have been S7, and it turns out that D5 cross S7 is isomorphic to S7 cross D5. And it's always like that. Okay.